My name is Dan Pan, and I'm founder for Haddee Education. And tonight, actually, I'm in our Haddee Center, Haddee Educational Center grand opening in San Diego. Professor Yang was here with us yesterday, so I'm going to have quickly show. And we'll have some in-person class here. We put a lot of flags for the colleges that our kids get into. And then some services, big cow flag. Okay, so anyway, I'm gonna turn YouTube. Yeah, so if I think most of you guys know about Haddee, but if you don't, we actually had a Google review. Will resume over 255, so you will see it in a few days, hopefully. And one of our landing page, we have multiple landing pages. They all point out the same thing. And we provide college counseling courses, summer programs. Ms. Mauro here, and we had a fabulous, challenging, rewarding, fun AI summer program at UC Berkeley. Residential and commuter students all joined us. So maybe next year we have a couple of seasons. And so watch out for the announcement for summer camp at UC Berkeley. And then this is our website. So I'm going to go show today. We really have 3 very interesting courses. I'm going to let them introduce, but you can find out here. One is the AI Academy. I think so. Yeah, we'll send you all the link, which Ms. Mauro will show. It's AI Academy here, right? It's all here. Yeah. Schedule, students' number, details. You can enroll here. Okay. Yeah. AI Academy. And then the other one is the way you look at it is mobile. If you open up the PC, it's a little bit different. It's Professor Yan's AI powered, and also everything's here. All the syllabus they will share is all online, very detailed, and you can enroll through our website. And last one is Coach Liam. And Liam actually is Ms. Mauro's high school student and enrolled at UC Berkeley. He's supposed to graduating, but not yet. Computer science and let me see the Liam. We have a multiple Liam classes. Okay, so that's elementary. It's not for elementary school. It's for lower level discrete math, which is not college level, for middle school and high school students. And all this is all here. And there's, if you click introduction, you will see much more. So we'll send all the links there. And Liam already came to talk to us a little bit, but we'll give a little bit more time to Liam as well. So I'm gonna stop sharing here, and I'm gonna have you guys very briefly introduce yourself, and then we'll give the sharing on the screen to Mr. Mauro. Okay, Mr. Mauro, go ahead. Mm-hmm.
All right. Hey, everybody. Thanks for coming. Tony Mauro, and I am an electrical engineer by training. I worked in San Diego at Qualcomm. That's where I met Dan. And I worked there for about 20 years. And then I transitioned into the classroom about 10 years ago. I taught both at the high school, community college, and at the university level. I retired from the high school about a year ago, June, and but maintain teaching at UCSD. So I'm located in the Bay Area, but I teach remotely through UCSD Extension. And so happy to be here. And yeah, as Dan said, we had a pretty successful summer camp just a few weeks ago. It ended and had a lot of fun doing both machine learning hardware and software. So I'll talk a little bit about a more extended program with that tonight. All right, thanks.
Okay, thank you, Mr. Mauro. And then we'll go by Coach Liam, please.
Hi, I'm Liam. I go to UC Berkeley. I've been studying computer science and math. I have a lot of experience in many sort of domains, but currently my goal is to pursue a PhD in pure math. So a lot of theoretical math, and in particular, logic and computability.
Very good. And Professor Yan.
Hey, good evening, everyone. So my name's Yang. I'm an assistant professor from the Department of Mechanical Engineering at SDSU. So I graduated from UCLA and then did my postdoc at USC. So before joining SDSU, so my research is working on the bio-inspired 3D printing, and we build some wearable devices, and also for the super surface and interface applications. Yeah, thank you.
Okay, very good. Okay, so Mr. Mauro, I don't know what happened. I can give you make a host, then I will lose the host, and then you can give to Professor Yang, and then last Liam. Okay, so
Okay.
yeah, I don't know why. So change your host. You here you go. Mhm.
Okay. All right, folks, I think I'm sharing. Hopefully you see the front slide. We're going to talk about two things today, and I'll try to be quick so that that the other guests have time to work through their programs. We've got two of them. We call the first one the AI Systems Academy, and then the second one is we call it AI Research Programs. And what we're really going to be focusing on are fundamentals of machine learning and kind of the foundational components of artificial intelligence, both in the software and the hardware perspective. In one of the programs, the Systems Academy, and then in the other one, it's going to be more directed studies and research programs for those who want to attempt to submit it for a publication. So again, I'll go through this stuff quick. We'll have these slides available to you if you want to review them. The Systems Academy is a really just sort of a comprehensive program that covers lots of components of software and hardware. What I try to do is kind of merge them together so that you get a good feel for both components. They're both very important in this field, right? In AI, not only just the algorithms part, but also to know efficient techniques for implementation. And so we cover both. We sort of split the time between the two. And so there's part one we call programming and algorithms for ML, and then the second one we call digital circuit design for ML. Programming and algorithms cover, I have this diagram that covers a lot of different parts of it. We have some math components to it. We have core algorithms in machine learning that are covered. Parts of deep learning are covered, and then those form the base for natural language processing, which I do in more advanced settings. Not part of this academy, but we're putting together programs for that as well. We basically have the software component sort of separated into three bins. One is the kind of a deep dive into Python and the math needed for machine learning, including libraries, and then machine learning algorithms. So we cover lots of different algorithms that I'll talk about when we go through a little bit more detail. And then deep learning networks or artificial neural networks. That's on the software side. On the hardware side, we go through sort of a mostly on digital side. So there's a large component of electrical engineering on the analog side, but digital side is what we concentrate on because that's where most of the architecture and design implementations are created for accelerating transformer algorithms, for example, and some of the stuff that companies like NVIDIA do, for example. But we'll cover it from a base perspective, fundamental combinational and sequential logic components, their applications. We'll get into hardware description languages, specifically Verilog and System Verilog, and then we'll apply those to applications in machine learning. Specifically, we'll implement a neural network in an FPGA platform. So the program for the Systems Academy comprises 72 hours of total total instruction, broken into 2 semesters of 36 hours apiece. And so you can see this. I won't go through every single line here, again, just to respect others' time. But you can see how it's broken down into either 1 or 2 sessions. Kind of the accumulated hours are shown, and then what are the topics that we cover, where they're split between software and hardware. So we'll take half of the session, we'll talk about and lecture on software topics, and then half of it will be on the hardware side. And along with each one of those sessions, we have work to do, some projects and assignments that are done by the students on their own. We get started with it. I give you lots of templates and hints along the way, and then work on those on your own, and then come back. And then the next session, we'll go through those and then cover the next topic. But you can see that we'll do lots of fundamental projects in Python, and then we go into sort of the math components of it, and then cover one of the popular algorithm, gradient descent. We look at EDA, exploratory data analysis. So this is just like data cleaning and prediction models, classifiers, clustering algorithms, and then we look at operations to accelerate these on hardware components. So all of the hardware parts are building up so that we can create accelerators. In the second semester, we get more advanced. So we cover neural networks there and applications to those. At that point, with the hardware side, we're doing Verilog, hardware description languages. So now we're able to code up more generic functions and more complex functions in what looks like a software programming language, but it's specific to hardware. Many different topics are covered there, with a focus on being able to ultimately create a neural processing unit in hardware. So that's would be like a CPU, GPU, and an NPU. Neural processing unit are very popular these days. We have final projects in those as well. All right, again, I'm going through this pretty quickly, but we'll have these available for folks. The systems research side is a 12 session. This is 18 hours total. It's a research focused program where students will be provided the kind of the tools to be able to do research, and guided instruction through that process to be able to create and write, submit a paper. And so we have many different forums that we submit to, mostly geared for high school students or entry-level college, but nothing like graduate level submissions of papers. It's more for high school and community college level introductory type papers. So in there, what we do is we cover just really lots of information about how you go about creating a research project through, if you go to graduate school, this is the kind of the thing that you'll do. You'll be working with an advisor, but if you're coming up with your own project, you have to be able to go through these types of these hurdles, essentially, to get through a research landscape, understand what the methodologies are for research, and what databases you can use, figuring out what project you want to go after, to identify some gaps that might be ripe for research. And again, it doesn't have to be brand new. You could be doing something on top of an existing algorithm or technique. But if you wanted to be accepted in the publication, you have to have something, got to try to get something that's a little bit novel. And then we'll cover literature review and research design. So again, just sort of putting the pieces in place that will allow you to be able to write these papers for submission. When you select your project, you can do either for me, if you're working with me, it'll be either a machine learning / AI, either software or hardware project. Those are the ones that I will work with you on. If you have something that's that's outside of those those areas, then I probably am not the right person to be working with. But in those two areas, I can help with the guidance on that. I'm not writing the paper, you're writing the paper. So in this case, you're doing all the work. I'm just helping guide you through it and then help you when you submit and you kind of go through the cycles of getting it accepted, hopefully. It's no guarantee that you'll get your paper accepted. You can't guarantee, nobody can guarantee that. But if you prepare it well, then I think you have a good shot. So we'll do research implementations where you're actually implementing your algorithm, collecting data and analyzing it, and then going through the tech writing phase of it, looking to see if you have any intellectual property. I have a registration number with the U.S. Patent and Trademark Office. I'm a patent agent in addition to some of the other things that I do. So I can help if you want to try to patent something or at least submit for a patent application with that. And then we go through the publication strategy on finding the right forum to submit to and preparing for that. And then we wrap it up with the actual submission and a presentation at the end to kind of show off your project. All right, I think that's pretty much it. There's some prerequisites in preparation. I'll make this available to folks who are interested in the program and can give you more information about it as needed. All right,
Yeah.
well, thank you. Thank you.
Thank you, Ms. Mauro. So just be very clear, the AI System Academy, it's the two programs are small group classes, the 3 hours on Sunday morning. If we have students joining in Bay Area, we can open up our Berkeley office for Mr. Mauro to come and teach in person. However, we will have two TAs have signed up from Mr. Mauro's summer program here in San Diego, and we also have a college student TA from Purdue in Chandler, and we collaborate with the Green Apple Academy, a Chinese school. So, but we need to assume that we have students, so that's more a hybrid. And but if you are in those 3 centers, you can collaborate with each other, collaborate with TA. And we set up really nicely. We have very nice, this looks small, but it's pretty big. And it's fun, okay? However, if you are not in the 3 cities, you want to say, hey, log in New York, you can log in as well. Mr. Mauro, you do the same assignment and etc. So those are small group classes. The research, the bar is much higher. You will have to go through the academy, basically like a summer program. Summer program is about more than 60 hours. Instruction 60 hours, but Ms. Mauro was there maybe 8 hours, 10 hours a day. So, and students gone through that program and can apply for the research. And however, if they're college students or advanced junior, seniors, they want to apply for become research and working on the AI paper, we accept as well, but Ms. Mauro will do individual interview. But students who we know very well already gone through our intensive summer program will bypass the interview. Also, research, the cost, nothing is shared, and it's we're going to provide more details online. We don't have yet. The academy is a small group classes. Okay, so I want to be very clear on that. Okay, so Ms. Mauro, can you give the sharing, the make host to Professor Yan, please?
Yeah, how do I do that?
Oh, you go to click Yan's Professor Yan at the end on the name, and then click more, then make host. If you look at participants, click at participants first. Yeah. Thank you. Yeah. Okay. You're muted, Professor Yan. We cannot hear you.
Oh, sorry. Yeah.
Yeah, very good.
Okay, so here, this is the on the website that the AI powered intelligent 3D printing system course on the Haddee website. So so this course is we focus on the the fundamentals of the additive manufacturing, which also we call 3D printing. So different 3D printing processes, materials, which material will be used for the like metal, polymer, ceramics, the structural designs, and then how do we use the AI machine learning to use it in the 3D printing process, use it in the model design, and use it for the real applications. So this will be 12 times. That will be each time will be 3 hours, Saturday afternoon, so in person. So we'll talk about the principles, basic principles of the different types of the 3D print technologies like FDM, SLA, SLS. So yeah, and then we have the virtual tour of the 3D print lab, and then the principles, application of different materials used in the different 3D printing technologies. And then so in situ monitoring. So how do we use this? Because the machine learning or the AI, we based on the real data, right? How do we use some like sensors, somewhat acoustic sensors, to collect the data in the 3D printing process? And then the basic introduction of the how to use the CAD software to design the 3D models by yourself. And then we'll bring a 3D printer to the classroom. So students will learn how to use the 3D printer. So after they design the models by themselves, they will directly use the 3D printer to print a real object, to print a real model. So that machine learning, basic introduction of this machine learning, and then deep learning and smart manufacturing. So basically, how do we use the machine learning, deep learning with the how to use the in the 3D printing process and for the smart manufacturing. And then I will talk about this bio-inspired 3D printing. That's my research expertise. So, and then we combine how do we use the machine learning with the bio-inspired design and 3D printing for the real applications. And then, so this 2 classes, 11, 12, will have this a small project. So students will, like 2 or 3 students will be one team. So they based on their interest. So, and they will do a small project, and then they print it out. And there's like a 5 minutes team presentation. So this I think this helps a lot for the training of the students, how to do the presentation and how to start and finish one small project. Yeah. So yeah, after this we have the research. I will just yeah, just like 2 minutes, just a brief introduction on my research here. So if you can you see my slides here?
Yes, we can see
Okay,
it. Very
yeah.
beautiful.
Yeah, just a quick introduction. So my research is working on called bio-inspired 3D printing. So in China, we have a saying, right? Like 师法自然, right? Which means that nature will be our teacher. So we'll learn from the nature, like the seashell, the fish scales, because they're lightweight and strong. So we learn from the microstructures, how do they use different materials to build this component materials with exceptional mechanical performance. So for the other, like we have here like interface, basically we use the macro scale 3D printing. We build this we call the super hydrophobic interface structures. And also we have like shark skin, so which we use microscope printing for the application in the drag reduction, like the bottom of the ship or on the clothes for the swimming. Like shape changing here, we call it 4D printing, which means after 3D printing, we use stimulate like a light, heat, temperature, or like a pitch value. So there will be shape changing for the 3D printed structures. So electrics, we have like wearable devices like piezoelectric or piezo resistant structures here. Optics, we have macro nanoscale like for the optical applications. So my research here, there's areas here we we have wearable electronics like thermoelectric devices. We use these wearable devices to harvest energy from the waste heat on the human skin. So others, we have the bio-inspired like smart composite structures. So we learn from the cuttlefish bone, we learn from the methane shrimp, and we learn from the nickel or seashell, or we learn from the cactus for the water collection application. So we also have the 3D printed ceramics project on the like 3D printed bones, or 3D printed the piezoelectric ceramics for the energy harvesting, or for the ultrasonic imaging application. So I just show for each project, I just show like one example. So we have the wearable thermoelectric energy harvesting here devices. We use the this thermoelectric devices. We build a stretchable because traditional thermoelectric is very rigid and hard, so you cannot attach on the human skin. So we build a stretchable devices. We attach on the skin. So when there are temperature difference on the bottom, top and bottom side of this devices, so there will be voltages generated. So basically, we collect the voltages. We collect the we do the energy harvesting from the because of our skin. There's temperature difference on the skin with the air. So there's we use this thermoelectric device to do the energy harvesting. So for the cuttlefish bone, sorry, I just because of the time limitation. So this is a recent project we learned from the cuttlefish bone. So the cuttlefish live in the deep sea area. So the deep sea area is a high pressure. So which means the bone, they are high pressure resistance capability. So the interesting the exceptional performance comes from the interesting microstructures of the cuttlefish bone. So because you can see it's very complex, so it's hard to be replicated by the traditional manufacturing process. So we use the 3D printing, we use the CAD design to design the 3D models, CAD software design 3D model, and then we print it out. Then we used we develop new material. It's rochelle salt, it's crystal. Then basically we grow the crystal, piezoelectric crystal in the into the like scaffold structures. So we build a multifunctional component materials. So which means, so then we did application. So piezoelectric means when you apply force, so there will be voltages generated. So we build a smart armor here. So which means when there's impact applied on the armor, so there will be voltage generated. So we can work as smart armor, not only for the mechanical protection, but we can also work as a sensor. So it's the material itself, the armor itself is a sensor. So we can collect the data during the football games. So this is on the CBS News for this work. So so the macro scale printing we learned from the plant called Savannah molester. So they have a very interesting egg beater shape structures on the leaf surface. So we use macro 3D printing, we build a super hydrophobic structures. So and the applications is in the like oil water separation, or we can do the droplet transportation, droplet macro droplet manipulation. Yeah, so we can do the water, the oil collection, so absorb oil. This is from the cactus. There's cactus everywhere here. So we use macro printing. We can collect water, the fresh water from the fall. Yeah. So for the bones, we have projects on the 3D printed bones application. So we use the hydroavitide, which is same material as our the human bone. So we use ceramics 3D printing. We build this bone for the then do the implantation. So yeah.
Okay.
Yeah.
Okay.
Thank you. Yeah.
Okay. Wow, this is very detailed. Thank you, Professor Yan. So I just want to say, with both professors, both teachers, Mr. Mauro and Professor Yan, they all have experience helping students through publication. And Mr. Mauro's students, multiple students, right? So one of them I remember pretty well, got into like Stanford, Harvard, a bunch of schools for machine learning, because we started working with students in machine, educating them on machine learning skills a few years ago, very advanced. Mr. Mauro, the school taught CCA, sometimes as high as 12 kids got into MIT each year. It's crazy. And Professor Yan, I know you have some high school students working with you or got into UC Berkeley, UCLA, and many other great schools. Okay, so
Yeah.
research is very important. However, before, if your students are very advanced, they all know all the foundations, you're welcome to apply for research program, and you can, send us an email and we'll share all the details. We have all research in one PDF we'll share with all the parents and the students. And if your student have not gone through the training yet, because those skills are not taught in school, we are very advanced in equipped, arm you with advanced skills for physical AI, really physical AI. Because computer science, you can go to vibe coding, and people like me, I never wrote code, I'm developing apps. However, physical AI, robotics, and self-driving cars, and many other things are like really, really the next in thing, much more gonna be popular or everywhere. We talk about SaaS. I tell students that's RAS, robots as a service. Okay, so I'm going to stop there right now. And both teachers requires assessment. Some Ms. Maros requires Python assessment. So just let you guys know, it's starting 9th grade. We look at the data. About 40 students submitted Python, 15 passed. So 15 came to summer program. They had a great time. For Ms. Yang, we also have assessment. That's a requirement. So I'm going to have Mr. Yan, you can, Professor Yan, if you can give the host to Liam, and then Liam can talk about the discrete math. Yeah. So why we're changing hands for the screen sharing, just want to, Coach Liam has TA'd quite a few classes. So please share what you have TA'd at UC Berkeley and your 4.0 student computer science and math. That's very rare. Okay, so I think, and you love teaching. So go ahead, Liam.
Yeah. I started TAing, doing core staff, so which means I support the professor with grading and leading the discussion section, leading office hours. My freshman year, in my first semester, I started teaching discrete math. I continued on with discrete math for another 2 semesters. After that, I taught algorithms. And after that, I taught probability and random processes. And I taught deep learning, so, very modern AI techniques for 2 semesters. And after that, I taught I taught quite a few math, like pure math classes, like real analysis, linear algebra, abstract algebra. Yeah. So quite a few classes. Oh, you're muted.
Yeah, very good. You're very qualified. Okay, even though you're not professor, like the other guest speakers. Okay, so go ahead, Liam. You have the host. You can share. And I will have to leave in 8 minutes. I will leave my cell phone number, our company email address, and WeChat. And if students, the parents are still confused, so you go on the link. The first thing is to have your students, for each class, whatever you want to take, it's you trying to pass the test. It's important you pass the test, okay? Then if you still don't know like how to enroll, we have a customer service, whole team to help you enroll, right? And then the beauty for the whole thing is that we promote our own students to be the TA. So like Mr. Mauro's summer camp students, and 2 of them already committed for the TA in helping Mr. Mauro in San Diego. So the TA will really be good experience to reinforcing your learning, and also be super good extracurricular, okay? So that's benefit number 1, volunteer opportunities, right? But of course, in addition to learning is benefit number 1, and volunteer. and once you volunteer, you're also learning, right? By helping others. Number 3 is if you are really ambitious and you want to put a lot more hours to get paper published, you have both of them help you with the paper. So there are so many long-term benefits for this program, and it's all very cutting edge, okay? Same thing for Coach Liam's class. Of course, math, you don't really need to publish paper much. You need to solve problems. So Coach Liam, also you can be a TA and learning first, because that's not overlapping with the Common Core. The AP calculus is completely different, okay? And then next spring, you can also support Coach Liam PTA online or physically in Berkeley or in San Diego. So I want to finish that because I'm going to leave in about 5 minutes, okay? Liam, go ahead.
Yeah. So discrete math is a very important class that all computer science and math majors take. It is like the class that bridges between the basic math like calculus, discrete differential equation, linear algebra, to the more advanced math that CS and math majors take, like algorithms typically follows, typically probability also follows. So it's the bridge between, the high school type math and then the math that, actual researchers will actually interested in. It's also typically the first class where people are introduced to logic. So like formally introduced to logic and sets. So it's a class that like provides all like the mathematical tools that students need to do literally anything in any sort of formal science, like mathematics, computer science, or statistics. So I will be teaching this class at a level that's more appropriate for middle school and high school students. This class has like the types of things you learn in this class are not present in any sort of middle school or high school education. So it should be very interesting to students. So discrete math typically focuses on things that objects that I guess people think of as discrete, so like separate objects. So some things that might count are things called graphs. Other things that people are interested in discrete math are counting. So figuring out ways to count the number of objects that sort of exist given certain parameters. The last thing people are interested in is in number theory. So learning an example of number theory is like if today's a Tuesday in 1,000 days, what day is it? And then people can use pretty, simple techniques in number theory to determine what day will be in 1,000 days if today's a Tuesday. So essentially the objectives are to learn the basics of discrete math, so involving counting, graph theory, number theory, and logic, and more importantly, to develop very strong problem-solving toolkit for more advanced courses or more advanced studies in computer science or math. Additionally, we'll be exposing students to a bit of proofs. Proofs are very important in both computer science and math. You need proofs to sort of show things are actually true. The most important thing people working on regarding, proving things in computer science has been P versus NP. So very important problem. If you solve it, you get $1 million. Also, all our encryption software is based on it. So that's, reason to learn proofs. Okay, so as a prerequisite, all students need to take a very quick exam. It's not very hard. It's just meant to be the basics of what every student should be familiar with. There are things like, do you know what prime numbers are? Are you able to solve for X in certain like very simple scenarios? Can you do basic arithmetic? All this stuff should be you should be very fluent in it before taking the class. Because I don't want this stuff to be a hindrance for you learning the actual material. Like for example, in counting, if I ask you to do some sort of basic counting, or I want to ask you, if I have, 10 socks and 5 shirts and 3 pants, how many ways can I make an outfit? That should be instant. Being able to multiply numbers should be instant. Okay. I think the date here is wrong. It's going to be starting later after Labor Day, but the time is correct. Sundays, 1:30 to 4:30 Pacific time, so California time, starting after Labor Day. There will be 12 sessions. Okay, so every session should have problems and also lecture. So I'm going to give lecture about, what the topic will be for today, and then the most important thing is doing problems. So at this level, doing problems is very, very important. doing problems in mathematics and computer science will remain to be important for the next, coming 10 years of your education. That's how you learn things, and that's where you make mistakes, where you struggle through, but that is the best place to be learning things. So I'll also be giving short weekly homeworks, and then there's going to be 2 exams just to check in, see what you're doing, let you know what you're struggling on, see if we can help you out with that. I also have a policy where we have no electronics, just because there's no need for that in class. Typically, they're pretty distracting. We'll be giving paper and pencils if you need them. Okay. The schedule. So logic is typically the first thing taught in discrete math. So you think of logic like, oh, if I am a cat, then I eat cat food. So, and I ask, okay, if I am, less than 2 feet, then I am a cat. So therefore, if I am less than 2 feet, then I eat cat food. Those kind of things. So typically you see these kind of things on like you learn these things generally in a math education, as well as like if you're studying for like a law exam, just basic understanding of how things, how implications work, how like statements work, like P and Q, I am a cat and I am less than 2 feet tall. These sort of and or statements are also very important, both in math and computer science. We'll also be teaching a couple techniques for proving things, as well as induction and De Morgan's law. So this like part will like intersect, a lot with a computer science education at the college level. Very standard stuff. Everybody needs this. After that, it gets a bit more interesting with combinatorics. So we'll be teaching some ways to count objects. Combinatorics is about counting things. So I'll teach you some, principles of counting, as well as showing you some cooler things within combinatorics, cooler ways to count things, and interesting ways. And has very strong ties to probability, because probability is just discrete combinatorics. So combinatorics on finite objects, or discrete probability is combinatorics. Okay. The third topic will be number theory. So number theory is the foundation of all encryption. So any digital security type thing is all number theory currently. We'll be teaching you basic number theory, about mostly has to concern with prime numbers and modular arithmetic. So remainders, dividing things, very important stuff. This you should have been taught prime numbers in school, and we'll expand upon that a lot to teach you things that are very interesting and useful. After that, we'll talk about graph theory. So graphs is like probably the most important piece of theoretical computer science is within graphs. You'll see a lot of things are actually just graphs. For instance, a graph is just some set of like nodes, like dots with like edges connecting the dots. I can think of the dots as anything. I can think of them as people, and then I can connect the dots if the people know each other. So Facebook, Instagram, all these social media sites use these like mathematical graphs to actually do their processing and model how, you're friends with 10 people and they're friends with more people. It's all modeled as a graph in their backend, and they use very advanced graph algorithms to make sort of decisions about how they should, recommend friends to you. We'll talk about graphs and a couple cool properties about graphs. And finally, on the last week, I'll be teaching special topics. So this will be a week where you're not expected to sort of understand, but it's just cool things within math. We'll talk about things like infinity, and we'll talk about things like how some infinities are greater than other infinities. Talk about a proof that some very old guy called Cantor did in the either late 1800s or early 1900s, showing that some infinities are actually just greater than other infinities in math, and we'll talk about the techniques that they use to do that. So upon completion, you should be able to obviously understand the topics from the class, but the main thing I want you to take out of this is very good problem-solving abilities. Discrete math is the first place where you really have to like do something new and not just follow an algorithm. You have to like, think creatively to solve some problems. So you might get a bit of a brain stretch on this one. Yeah, so that's my course. If you're interested, ask me any questions. But yeah.